Hey mathematicians, here are your notes for 6.2. Today we're going to be talking about graphing inequalities, but while we talked about addition and subtraction yesterday, today we're going to be talking about multiplication and division. Quick bell work. If an inequality has a line beneath the symbol, meaning it looks like one of these, what does that indicate? Take a minute to answer yourself. All right. An inequality that has the line beneath the symbol means that it is red or equal to. So whatever value we're talking about is also included. If I have an inequality that says x is greater than or equal to 2, that means I include 2 in my solution. All right, goal for today. I can graph an inequality with one variable using multiplication and division. Consider this. You're trying to save up for a new phone case. Your goal is to have $25 more than the price of the phone case itself. If P is the price of the phone case and B is the amount in your bank account, write an equation that models the amount of money in your bank account at the end of the month. So, the money in my bank account has to be equal or greater than the amount that the phone case is plus 25. So my bank account is going to be greater than or equal to the price of the phone case, P, plus that $25. But Miss Murray, this doesn't have to do with multiplication and addition. You're right, but we wanted to review that addition and subtraction because multiplication and division is tricky. We'll work with this more later. How would we solve the following inequalities? Well, remember how yesterday we talked about inequalities and equations being very similar when we solved them. So if this were an equation, I would divide both sides by 4. With an inequality, I get to do the same thing. I divide both sides by 4, and I get x is greater than 2. I'm going to find that important number on my line, and I'm going to graph. Notice this doesn't have the or equal to underneath, so 2 isn't going to work. But numbers greater than 2 should. Let's check that. I'm going to check the number 3. 3 times 4 is 12, and 12 is greater than 8. So these values work. For this one, in order to solve, I need to divide by -4. When I do that, I get that x is greater than -2. Now, -2 doesn't work, but any value greater than -2 should. The easiest value to check that's greater than -2 is 0. Let's plug it in. 0 times -4 is 0. 0 is greater than 8. Wait. 0 isn't greater than -8, so values to the right don't actually work. Well, let's check values to the left. Let's check -3. If I plug in -3, I get -3 times -4 is positive 12, and positive 12 is greater than 8. So values to the left work, even though this says that values to the right should? Why did that not work? Well, in math, there's a special rule to follow when we're working with inequalities. When you multiply both sides by a negative value, or divide, you make the side that is greater have a bigger negative number, which actually means it's now less than the other side. That's kind of confusing. But this is why you must flip the sign whenever you multiply or divide by a negative number. So if we go back to our original problem, we found out this wasn't true. What I needed to do instead was when I divided by that -4, or when I multiplied, I have to flip the sign. X is less than -2. Now this is a true statement, and it makes my number line work. Let's see some more examples. 15x is greater than 75. I can solve that pretty easy. Divide both sides by 15. There's no negative involved, so I just bring the side down. 75 divided by 15 is 5. I check myself, plug in a value. What's a number greater than 5? 6 is greater than 5. 6 times 15 is going to be 90. Is 90 greater than 75? Yes. So I checked my value. I'm good to go. The next one says 3 is less than m divided by 3. If m is being divided by 3, the opposite is multiplication. So I multiply both sides by 3 to solve. I get m is greater than 9. But that's not how I want to leave my answer. Make sure you flip it so that the m, or your variable, is on the left-hand side. Let's check it. What is a number greater than 9? 10's a number greater than 9. Let's check it. 3 is less than 10 divided by 3. 10 divided by 3 is about 3.3. Is 3 less than 3.3? Yes, it is. So we checked it and it's good to go. The next one is a little tricky though. I see a negative, so I know that when I divide by that negative number, I have to flip my sign. I don't have a greater than anymore. I have a less than. 6 divided by negative 3 is negative 2. Let's check it. If I put in a number less than negative 2, like negative 3, does it work? Negative 3 times negative 3 is 9. 9 is greater than 6. This is a good answer. Try the next two on your own and come back. All right, hopefully you had a minute to try those on your own. This one, 2 is being multiplied by x, so I divide. I get x is greater than or equal to 7. I flip my answer around, x is greater than, and I test it. Nice easy number would be 10. 10 times 2 is 20. 20 is greater than 14. This is a good answer. And the last one, a little hard to see, but x divided by negative 2 is greater than negative 1. X is being divided by negative 2, so I need to multiply it by negative 2. And I do that to the other side. Those reduce to 1. I get x is less than positive 2. Notice because I multiplied by negative, I flipped my sign. Easy number to check is 0. 0 divided by 2 is just 0, and 0 is greater than negative 1. There it is. So, your final rule of solving inequalities, make sure you know that when you multiply or divide, by a negative, you need to flip the sign. All right, go practice, and if you have any questions, let me know.